Hello, so I wanted to do a video today on finding the equation of a line but not using the graph. You're just using two coordinates that you are given that lie on that line. This is a grade 5/6 topic at GCSE, and I do have three examples to go through that are going to look like these sorts of questions on the screen now. So before we get into it, there are a couple of areas that you need to be comfortable with. The first of those being if I gave you a graph, for example, something like this. Let's scroll. Let's move that so you can see it. No, I won't. I'll just draw it down here again. If I give you something like that, you need to be able to find out the equation of that line just from the graph. You also need to be comfortable with operations with negative numbers. So if you're not completely comfortable with both of those topics, it's a good idea that if you were to go away and have a look at those before revisiting this. Okay, so rather than drawing out the graph or being given the graph, you are given two coordinates and you need to find the equation of the line that passes through both coordinates. Now you need to remember that the equation of a straight line is always y equals mx plus c. Now m here represents the gradient of the line, and this bit here, it could be a minus c as well, represents what we call the y-intercept. That is the point at which That is the point at which it crosses the y-axis. So, for example, this point here, but again we're finding it from just the coordinates. So the first thing you're going to do with these sorts of questions is you can do a sketch of it if you want, just a quick rough sketch. So the point 311 would be up here somewhere, and the point 17 would be here somewhere, and there's a straight line. There's a straight line going through those 2 points, and we want to find out what the gradient of that line is. So the first thing I suggest you do with these sorts of questions is to label the two coordinates A and B. Now the reason for that hopefully will become a little bit clearer later on. Okay, so the first thing we're going to do is find the gradient of this line. So the gradient, remember, is the change in y divided by the change in x. You might also have heard it called rise over run. So I want you to be consistent with which coordinate you start with. So what I mean by that is to find the change in y. This, for coordinate A, the 3 represents my x coordinate and the 11 represents my y coordinate. And over here, coordinate B, the 1 represents the x and the 7 represents the y. So we're interested to start with in the y's. Now, whichever one you start with, you need to start with that one to work out both the change in y and the change in x. So what I mean by that is this. The change in y, I'm going to start with my A value. So the change in y is going to be the 11 from here, and we're going to take away from that the 7 from here. And we're going to put that over the change in x. Now because I started with the 11 last time, that tells me that I have to start with the 3 this time. So I'm going to do 3 take away 1. So the numbers we've started with for both the numerator and the denominator here have been the values of x and y from coordinate A. So you can't do 11 take away 7 on the numerator and then 1 take away 3 on the denominator. That bit is really important. So 11 take away 7 gives you 4. 3 take away 1 gives you 2, which tells me that the gradient here is 2. So that tells me, going back to this bit here, the y equals mx plus c, that tells me that my gradient, my m value, is 2. So I'm just going to write out y equals 2x plus c. Now, c does not change. It doesn't matter what the values for x and y are, that c value, that plus c or the minus c, will always be the same. So what we are now going to do is we're going to choose either the original coordinate a or b, it doesn't matter. I'm going to use a. So the coordinate a was 3, 11. Remember that 3 represents my x and that that 11 represents my y. So if I just substitute those values into this equation, the one where I've found the gradient, I will then be able to find out the value of c. So because my y is 11, I'm just going to put that in instead of the y, and then 2x means 2 times whatever x is, so in this case that's 3 plus c. So I now know that 11 is the same as 6 plus c. So because I want to know what c is, I'm going to take away 6 from both sides of this equation. So 11 take away 6 gives me 5 equals c. Now that 5 is a positive number. So now that I know what c is, the equation of this line is going to be y equals 2x plus 5. And if that came out as a negative number, for example negative 5, instead of plus 5 on the end, it would be minus 5. If you wanted to, you could always check that it works using the other value. So my coordinate b here equals 1, y is 7. We can just check that it works. This is our answer here, but we can just check that it works by putting these values of x and y in to see if they equal each other. So if y was 7, I'm going to write 7 equals 2 times 1 plus 5, so 7 equals 7. That tells me that I've got it right. Okay, so that's the first one. Okay, now for this second example, you need to watch out. You need to be careful when you are working with negative numbers. So, just as before, I'm going to call this coordinate A and this coordinate B. And we're going to start by working out the gradient, which is this m. So to work out the gradient, we're doing the change in y, and I'm dividing that by the change in x. Now remember, we need to be consistent here, so I'm just going to write out, this is my x value, x and y values for coordinate A, and these are my x and y values for coordinate B. So for this one, I'm going to start with, to work out my change in y, I'm actually going to start with coordinate B for a change. So I'm going to do negative 43, that's my value for my y value in coordinate B. And because I'm working out the change, I'm going to take away whatever my y value is in coordinate A. Now be careful here, because that y value is not 19, it's negative 19. And I'm going to divide that by my x value for B, which is 10, and we're taking away whatever my x value for A is, which in this case is 4. Now if I just tidy that bit up a little bit, be careful here, because remember, when I have two signs next to each other like this, this actually becomes a plus. So you're actually doing negative 43 and you're adding 19 to that to give you negative 24, and we're dividing that by 10 take away 4 equals 6. So 24 divided by 6 is going to be 4, but remember, a negative divided by a positive comes out as a negative. So this tells me that my equation is going to be in the form y equals negative 4x plus c. Now we're going to choose either coordinate A or B to use to work out what c is. It doesn't matter which one. I'm going to use coordinate A. So that was 4, negative 19. I'm just going to write that down here. We know that point is on the line. So the 4 represents my x, and the negative 19 represents my y. So I'm just going to stick that negative 19 into the equation instead of the y. And negative 4 times whatever x is, well, x is 4. And we're going to add c to that. So if I just sort out those brackets, I get negative 19 equals negative 16 plus c. So now I want to add 16 to both sides of the equation so that I then have my value of c. So if I add 16 to this side of the equation to get rid of this bit, and I add 16 to this side, negative 19 add 16 still gives me a negative 3. So that is my y-intercept. So the equation of the line that passes through those two coordinates is y equals negative 4x minus 3. And again, if you wanted to, you could check it by putting in the values for x and y to see if that works, but that's the equation there. Okay, finally, you might also get some questions that have both negative numbers but also some decimal places in there. Again, it's exactly the same thing. This is going to be my coordinate A, this is going to be my coordinate B, and we're always starting with the equation y equals mx plus c. And to find m, which is the gradient, we're doing the change in y, and we're dividing that by the change in x. So in this case, let's start with a this time. This is my x value, this is my y value, this is my x value, this is my y value. So we're going to start with coordinate a, so I'm doing the change in y. So I'm going to start with the y value, negative 8.5, and we're taking away whatever the y value is in coordinate b. Watch out, that's again a negative 12.25. And we're going to divide that by, I started with coordinate A, so I need to start with the coordinate A again, with my x value, 2, take away whatever my x value is in coordinate B, that's a 7. Okay, so if I just tidy up the numerators and denominators before I do the calculation, the denominator is a little bit easier here. 2 take away 7 gives you negative 5. And then I'm going to start with negative 8.5, and here, because there are two negatives next to each other, remember that becomes a positive. So we're actually doing negative 8.5 plus 12.5, which gives me 3.75. Now remember, a fraction is a division that has yet to be completed. So I'm just going to do 3.75 divided by 5, and that actually comes out as 3/4. Sorry, negative 3/4, because we're doing a positive divided by a negative. 3.75 divided by negative 5 gives you negative 3/4. You could write that as negative 0.75. It doesn't matter too much. I suggest getting into the habit of using fractions, because they are a little bit easier to work with. So negative 3/4 times by x, which is what the first part of the equation would be, is the same as negative 3x over 4, and I actually think that this is a little bit easier to work with if you write it like this. So remember, that's the gradient part, and now to work out the value of c, we're just going to use one of the original two. So I'm going to use a coordinate A, which was 2, negative 8.5, where 2 is my x value and negative 8.5 is my y value. So plugging these values in, instead of the y I'm going to use negative 8.5, instead of the x I'm going to use 2, divide that by 4, and then add c. Okay, so tidying this a little bit, negative 8.5 equals negative 6 over 4 plus c. Now I want to get rid of this. So as this is a decimal, actually, I might put this into a decimal as well. It might be a bit easier to work with. Negative 8.5 is equal to negative 1.5. 6 divided by 4, which is the same as negative 3 over 2, which is 1.5. And then we're going to add c to that. So to find out what c is, I actually want to add 1.5 to both sides of this equation. So adding 1.5 to both sides of the equation gives you negative 7 equals c. So now that I know that c is a negative number, instead of this equation which we used earlier, it's still going to be negative 3x over 4, but now instead of this plus c, we're actually adding negative 7. Now that becomes a minus. So my final equation is negative 3x over 4 take away 7. So that's the equation of that line there. Okay, so those are the three examples that I've from the question generator. I'll attach a link to this one so you can download it and get some practice. When you open the file, you must remember to click enable content in a little yellow ribbon that appears at the top. If you do not do that, the buttons will not work. So once you have opened these, you can it's automatically set to increasing difficulty, so you can generate some new questions and get all the answers. If you want to focus on a particular type of question, for example question 1, you can try some of those, and when you've got the hang of all of them, it's a really good idea to practice a mixture of them, because if you can do that, it shows a really good understanding of the topic. That's it. I'll pop a link to this file in the YouTube description. Hope the video's been useful. Thank you very much for watching. Bye bye.